What is a parabola? I have asked that question of hundreds of students. Students that spend 2 years studying parabolas, moving them around, translations, reflections, stretches, compressions, and they don't know what they are. Their teachers have never given them a definition of a parabola. I actually asked one of my students to ask his teacher what a parabola was, and sadly the teacher couldn't give him a definition either. So if you're one of those people that have been studying parabolas and have never been told what they are, this is a video for you. Now, a parabola simply is a set of points that are all the same distance from a fixed point called a focus and a fixed line called a directrix. A little more complicated than a circle that just has a fixed point called a center and the distance remains the same. Here the distances keep changing, although the distance to the focus and the distance to the directrix are always equal. So the point A is the same distance from the focus as it is from the directrix. The point B, same thing. That's the definition of a parabola. Now, what I'm going to do is I'm going to take this definition and I'm going to show you that it leads to a quadratic equation. Now, in order to do this, I'm going to refresh your memory on the distance formula. If you remember the distance formula, then you can skip ahead on the video. But the distance formula for 2 points in a coordinate system is very simple, actually. The distance from A to B, all we need is the run and the rise from A to B, because the Pythagorean theorem tells us that the square of the distance from A to B is equal to the sum of the squares of the other two sides. So here's the run, difference in the x values. Here's the rise, difference in the y values. And to get the distance formula, then all we have to do is take the square root of both sides. Now remember, you can't just take the squares off these individual terms. It doesn't work that way. You take the square root of this, remove the square, and take the square root of the other side. And that's the formula that I'm going to use. I'm going to fit that formula to the definition that I just gave you. Okay, so what I did was, in order to make this as simple as possible, I put the focus on the y-axis 1 unit above the x-axis. And I made the directrix 1 unit below the x-axis. That means that my vertex is going to be at the origin. You can do this anywhere in the plane, but I wanted to give you the simplest possible explanation here. So we've got this point, I'm labeling it P, coordinates x, y. The focus has the coordinates 0, 1. And if you come straight down from the point to the directrix, the x values, whatever they happen to be, will be exactly the same because we're coming straight down. And here's the y coordinate here and the y coordinate below. So what I'm going to do is I'm going to take the definition, PF equals PD, distance from the point to the focus equals the distance of the point to the directrix. Okay, so here's my distance formula. I've just substituted in the coordinates. The x minus 0 here is this x minus the 0 coordinate for the focus. Same thing with the y, y minus 1. And for PD, exactly the same. The difference of the x's, difference of the y's. Now, this just disappears because those x coordinates are the same. That just becomes an x squared. And when I square both sides and remove the root sign, this is what we've got. So now I'm going to expand the y minus 1 squared and the y plus 1 squared. Most students like to write them twice so that they don't miss any terms. When I expand them, this is what it looks like. Now you notice there's a y squared on both sides. They cancel out. There's a 1 on both sides. Those cancel out. And if I move this negative 2y over to the other side, all I've got is x squared equals 4y. And if you want to put that in another form, a form that you're more used to, let's reverse the sides and divide by 4. So there you got it. Y equals 1/4 x squared. So that's a quadratic equation that we've achieved from that definition. So if you're one of those students whose teacher has never given you a definition of a parabola, now you know.